Good afternoon, guys. Welcome to another session of Evap discussions. Yay! Evap systems, they cause us headaches. They create all kinds of problems for us. We get vacuum leaks out of them. We have fuel tank filling problems with them. I've seen problems with the Evap system. You try to put fuel in the tank and you can't get in but 40, 50 cents and the pump shuts off. Long way, it's going to take a really long time to fill up that 20-gallon gas tank, especially in a bigger vehicle. Those are all problems related to the Evap system. Last time we looked at the type of Evap system that was on my Jeep. It was a system that used pressure in order to fill the tank up. That system did not have onboard vapor recovery. We did not use that. So we're going to look at three systems today. One of them uses vacuum to make it work. One of them is pressure to make it work. And the other one we're going to look at, it does use vacuum to make it work. So we're going to look at two vacuum type systems and one pressure type system. Now, keep in mind, these are going to be, all of these are similar to stuff that's used on other cars. The trick with Evap systems is, as I've always said in the automotive world, if there's a great way to do it, somebody will find a different way and do it. So different manufacturers use different systems. Most manufacturers have several different systems that they use. So we need to keep in mind, one of our first things that we need to do when we're tracing out anything other than just a normal leak, or if we have to do any specific type of testing other than visual, we're going to have to kind of read about this system and see how it works. We're not going to get into testing of it today. I'm going to do that next week for Monday and go through testing of the systems, things that you need to know, some tricks that I've learned that have worked real well for me. And you'll just have to try and see what works for you. But some things maybe you can keep in mind when you can't quite find your problem. You're probably finding your problem. It's just evading you. You found it, but you haven't seen it yet. So without further ado, let's talk about Evap systems, get that up and running, and take a look and see what we're doing. One of the first things we're going to look at is a system that was one of my favorite systems that Chrysler used, because it used one small component. So remember what our Evap system looked like. We've got gas tank back here at the back of the car. We have some hoses that hook it up to the charcoal canister. Then there's a hose coming out of the charcoal canister, goes up to the purge solenoid. And off of the charcoal canister is a vent. So to get the fumes, if we create fumes in the gas tank, those fumes go into the charcoal canister, they're stored. When we start the car up and we've got it running, purge solenoid opens up and we pull air from the vent through the charcoal canister, up through the vacuum lines to the purge solenoid and into the engine, and we burn them. Well, the system I just described to you, there's no testing for it. No way to test it, because we didn't put any components in it to test it. So this system, similar to the one that we looked at last time on my Jeep. We're just going to add a component in there that's going to do it for us. The other system, it was a pump. It was a pump that had a built-in switch. We slowly raised air pressure up, basically to somewhere in the neighborhood of about 3/4 of a pound to a pound of pressure. That's about it. That would close it. Then we look for it to decay. And we just added it in to the vent line. We're going to do the same thing with this system, but we're not going to add an electrical pump. Matter of fact, the only thing we're going to add is a switch, but we're going to put it in a housing with two very well calibrated weights. So let's take a look at what this thing looks like. This isn't the actual picture of it. This is a drawing to show you the pieces and what it actually does. So this is our ESIM switch. And to kind of give you some perspective of what's going on, my charcoal canister would be here. So this would all be my charcoal canister. So this piece literally there's a hole in the charcoal can. We take this piece and it has little fingers on it, kind of like a lock, and we put that into the charcoal canister. We turn it and it latches in. So it has to be mounted correctly. If it's not mounted correctly, it doesn't work. It has to be mounted exactly the way the manufacturer intended on it to be mounted. So make sure if you ever replace them, look at it before you take it off, and make sure you get it back on there correctly. Now, while I'm here looking at this one, right here and right over here, if I turn this piece, so this end was facing us, there's going to be an O-ring on there, really bad O-ring. Yeah, it's more like a D-ring. But the point I'm getting to, there's a seal there. That seal was really common for leaking, so don't overlook that, especially on some of the vehicles that would like to go off-road, because they would go off-road, they would get some dirt laying up in here, and eventually it would get down here on the seal just from heating and cooling down and slowly work its way in there and cause it to leak. So if you see a leak in that area, sometimes you can just take it off, clean everything up real good, lubricate the seal a little bit, just a tiny little bit of engine oil on it or a silicone, just enough to soften it up, put it back on there, and if that fixes your leak, great, it's just the seal leaking. I have seen that leak before. Now, over here on the other side of this, so our charcoal canister sits here, sits over here. This is our canister. But over here on this side is a hose that pretty much it goes to a vent. It goes to a vent. Usually sometimes it has a filter in it, sometimes it does not. Depends on the vehicle. And that's where our fresh air is going to come from. So this is going to hook right on there where the fresh air vent on the charcoal canister would be. So this is going to be that big hose on the charcoal canister. And we're not even going to put a hose on it. We're going to put the ESIM switch on there. Then the hose hooks onto the ESIM switch. So gives you an idea of where this item is located, right on the charcoal canister. There is a connector that goes to it, a 2-wire connector, because there is a switch in here. Right in here This is the switch. So the switch, you can see one terminal is here, one terminal is here. So the switch, all that happens with this is we're going to let nature do her thing. If you don't understand what I'm talking about a natural vacuum, if something gets warmed up and you seal it off and then it cools down, the pressure inside is going to decrease. It's what we call natural vacuum. If you want a good idea of how this works really fast, go take an empty 2-liter bottle or the plastic drink bottle, turn on the hot water on your spigot and fill it up with hot water. Dump that hot water out and immediately put the cap on it. You're going to have a lot of hot air in that container. Sit it on the counter and it'll probably take about 5 minutes and you're going to actually hear it crush itself. The air will shrink as it cools down. Hot air takes up more space than cold air. So it will actually create a vacuum inside of it and it'll crush the bottle all on its own. It's kind of neat. If you've never done that, try it. You'll understand what natural vacuum is. So what we're going to rely on with this is if my charcoal canister is here. So if I have a pressure drop, if the pressure drops in the charcoal canister, then that is hooked right through here. There's a passageway right there, and I'll erase that back out so you can see it. And there is a diaphragm that comes across here, and right here in the middle of the blue is a metal contact. So you see where I just draw, and I'll clear that off so you can see it. So now if this diaphragm pulls inward because vacuum drops, that will make connection across these two terminals and it closes the switch. That gives it its name, ESIM switch. This is actually called an ESIM detector. Stands for evaporative switch in module, means it's all contained in one. The switch and the leak detector is all in one. And so that creates the vacuum, pulls that diaphragm open or closed, and that closes the switch. The ECM sees the switch close, and it says, hey, we pulled a vacuum on the gas tank, on the hoses, and on the charcoal canister. We don't have any leaks. We pass the monitor. Very, very simple. Now, there's a couple other pieces in this, and these pieces will tend to come into play and create a couple other problems for us. Yeah, it's not common to get a code for the ESIM switch, but the code for the switch generally isn't due to a switch failure. It is generally due to a piston failure. There are two weighted pistons or valves, call them what you will, in this assembly, and they do different things for us. So let's stay with the vacuum. We've been out driving a car. Car warms up, heat during the day, warms up the gas tank. We shut the car off. It sits, temperature outside starts to cool down. And so pressure in the tank is going to drop. So the pressure drops, and we get about in 2 or 3 inches of vacuum inside of the gas tank, and that closes this switch down. So we did our job. We've sealed up the system. It all works. What if the pressure keeps dropping? What if it was really hot during the day and then it got really cold at night? Or the other scenario, you're driving along, you're using gas out of the gas tank. If you pull gas out of the gas tank, air's got to get in there. So it's got to get in there from somewhere. We don't let it go in through the gas cap anymore. There is some high vacuum, high pressure relief valves in the gas cap in case it gets to extremes, but they are very rarely used. Most cars now, some of the newer cars, they don't even have any relief valves on them, on the gas tanks. So that air has to get in to replace that fuel that we're using somehow or another. Or maybe the pressure keeps dropping. Maybe it was 80 degrees out here today and it drops down to 30 at night. The pressure is going to drop drastically, and we got to replace air in that tank or the tank's going to collapse. It's a plastic tank, and that could happen. I've seen that happen before. So here's what we're going to do. I'm going to get rid of the drawing that I have on here right now. And we have a valve. This is a vacuum limiting valve. So it is a valve, but it's actually a weight. So it has a very calibrated weight. It is set down inside of this component very precisely, so there's very little room for movement left and right. So it has to fit perfect. It has to be mounted exactly right, or it will not work. It will drag the sides and it won't work. So if we produce a vacuum inside of the tank, so if we have a vacuum in the tank, then we are trying to pull air out of this cavity. So air is trying to leave out of here, and it will lift this valve straight up. And right here at the bottom, at the very bottom of this, is you'll see an opening right there. So if that valve lifts up, we uncover that opening, kind of like picking the stopper up out of the sink to drain the water, and air now will be able to come in through the vent hose, come right in around here, up through that valve, and come over and replace the air that's in the tank till the pressure is relieved. And when the pressure starts to equalize, then the valve will drop back down. Really simple. No springs. It just goes off of the weight of the valve. And it's calibrated so it takes a lot more vacuum than what it takes to close the switch. Well, what if that valve got some dirt into it? Remember this air that's coming in over here from this fresh air? What if it gets some dust or some dirt in it? So there should be a filter in line. There should be a filter in here so we get fresh air in. It's not a replaceable filter. You can get them, by the way. You can get them if you have to get them if they become clogged. You can get them, but it's there to try to make sure we keep clean air. So if you get one of these sticking, don't be afraid to replace the filter on it along with it. If that air comes in and we get little pieces of dirt get in here, what if we had some pieces of dirt that got up on that seat? It could make that valve stick. Now we got a leak. Now this is our leak. We'll set a code for the ESIM switch because we never see it change states. But it could just be the valve sticking. Now, I will tell you, I have taken these out before and shaking them around, and you'll hear the valves moving. You shake them real lightly. You can hear the valves kind of jumping around in there. And I have done that before, put them right back on, and they would work. It would take care of my problem. Problem is going to be there could still be some dirt in here that the next time this thing inhales air, it gets stuck in that valve. So if that happens, get a new ESIM switch. I'm going to get this whole assembly right here and replace it. And if it's got higher mileage on it, or if there's a lot of dirt under this vehicle, looks like they live on a dirt road, or maybe they live on or they like to go off-roading, I'm going to probably get this filter and replace it along with it. Blow the lines out while you got it loose. Just blow some fresh air through them. Try to dislodge any dust and dirt that's in there and get it out of the line. Put it back together. It'll help get rid of a repeat failure. Now, what's the other version of this? I get up in the morning and get ready to go to work, and it's 30 degrees outside. Well, I head into work, and while my car's sitting outside, let's say it warms up to 60, 70 degrees outside. That pressure has built up inside of that gas tank. So there's got to be a way to get rid of the pressure. Now, if this is pressure now inside of here, pushing through, it's going to push this valve down. That's just going to seal it off even better than what it was sealed off before. So that's the job of this one right up here. So the piece on top that you see there, if we get pressure coming in, trying to get out of that tank, it's going to push up on this valve. It will move up, and now my air will go right through the side of this valve and right out through the filter. So the one on top relieves pressure in the tank. The one on the bottom relieves vacuum in the tank, and it doesn't take much. 2 to 3 psi, and the valve on the top dislodges and releases pressure. 4 or 5 inches of vacuum, and the one on the bottom is going to move up, dislodge, and allow pressure into the tank so we don't collapse the tank. Fairly simple system, right? Well, there's one more piece to this animal, and that is called onboard vapor recovery. So, for onboard vapor recovery, the EPA said that when a gas tank's empty, it's not empty. It might be a 20-gallon gas tank. It might have 2 gallons of gas in it, but that means it has about 22 gallons or more, 25 gallons of gasoline fumes in it. So originally, and this has happened in some states, they hopped on it early. I think California is one of them, maybe Illinois. Originally, they came out and they said, hey, you got to recover all those vapors. When you put gas in the car, if you put gas in an older car, you may notice the gasoline smell around the car. You may notice it's coming up if you stand there at the gasoline nozzle holding it. You're going to smell the gas fumes coming out of the vehicle. So what they did is they said, we've got to capture those. We don't want, every time you get gas, we don't want to put 25 gallons in volume of gasoline fumes out into the air. We've got to capture those and recycle. So originally they said we were going to have to take the filler neck, the nozzle on the hose, put a big boot on it, so when you put it onto the car, it's sealed up. That way it sealed it up, and those fumes would come out of there. They would get drawn down into the tank in the ground at the gas station, and that's where they would be stored. Then the tanker would come in. When he pumped fuel into the ground, those fumes would come out. They would go into the tanker. When the tanker went back to the gasoline yard, then they would have to pull those fumes out of the gas tank, out of that big tanker, and recycle and find some way to make them non-harmful anymore. Well, the gasoline company said, hey, that's not our problem. The fumes are in the car. They're not that's not our problem. The fumes that are created in the car, that's the car manufacturer's problems. So they tried to dump it on the car manufacturers. And car manufacturers said, we can handle it. Easy deal. So here's what they did. What they did is they went to this switch, and we made the filler tank. Look on the older cars. You'll find out the hose that comes down from where you put gasoline in the car to the gas tank. It's a big hose. It's a big tube, maybe about 3 or 4 inches through the middle. Not quite 4 inches, 2.5 to 3. And on the older cars, it was fairly big. Look at the newer cars. It's not even big enough to put a banana down through. It's maybe about 1.5 inches through the middle. So you're talking about a hole about that big. And so now when you're putting fuel in there, you have just enough room for the fuel to go down in that tank. So what's happening to the air? Well, remember the vent line that's on top of the gas tank. It goes to the charcoal canister. So what we're going to do with this system is when we're doing a refueling, our charcoal canister is this box sitting right here. It's got a line coming off of it that goes over here to our gas tank. I'll just draw a little gas tank, and here's a filler neck. So you're putting gasoline into the vehicle. We're pouring gas in here and filling up the vehicle. While we're doing that, the fumes that are in here, that are all up in here, they're going to go up and follow this hose, come through the charcoal canister. We're going to capture all of the hydrocarbons, and the air, the oxygen, nitrogen, what have you, will continue on through, and it comes out here. It pushes this valve off of its seat, and then it continues on out to the atmosphere. That's onboard vapor recovery. To give you an idea of things to think about, what if this valve stuck? Now when I put gas in, the fumes try to go out. They get into here, but there's nowhere to go. So pressure builds. That shuts off your fuel pump, your fuel nozzle, and it doesn't take very much. It happens really quick. If you can't get that air out, you're only going to get maybe 50 cents to $1 of fuel in. And when you're only putting about half a gallon at a time before this thing clicks off, and then you got to let it sit for a minute, and then you can try it again, putting a little bit at a time in the tank. If you got a big gas tank, like I do, a 20-gallon one, it'll take forever to fill this thing up. It can take you half an hour to an hour just to get 20 gallons in there. So it's going to take a really long while. So keep that valve up here in mind if you have a problem with putting gas in the car. That's called onboard vapor recovery. So let's take a look at another system that we're going to use. That's a fairly simple system. 2 wires, that's all we added to the car. 2 wires and a switch, just an on-off switch. If we pull vacuum on it, closes the switch, test is good. So let's look at a system. This system is fairly common, though the slides I'm going to show you are from Toyota. It is a fairly common system. So look at some of these pieces that we've got. I'll just point out a few of these so you realize that we're there. To start with, what's going to make this work is right here in the middle, we have a vapor pressure sensor. So this one, instead of being a switch, it's actually a sensor, and it's going to measure vapor pressure. This is basically a map sensor, same map sensor we used on the engine. On a lot of cars, it is the same sensor. I've had vehicles in that the vapor pressure sensor was kicking a code for it, and so I lowered it down. I took the vapor pressure sensor off of the top of the gas tank, and I switched it out with the one on the engine for the engine, and now the one on the engine was kicking a code. Real easy diagnosis. Now all I have to do is get a sensor and replace it. So this is, in some cases, it is the same sensor that we're using on the engine to measure manifold atmospheric pressure. It's just a pressure sensor. There is a valve, vapor pressure sensor valve, located right next to it. We're going to use it to decide whether we're measuring pressure in the whole system or just in the canister. Now, we've got a couple of pieces over here. Right on top of the tank here is a rollover valve and a onboard recovery valve. So this is the valve that's going to allow us to recover the vapors when we're refueling. We'll take a look at that here in just a second. Another valve that we've got down here at the bottom is actually 2 valves put together. There are 2 valves together right here at the charcoal canister. One's called a air drain valve. The other one is called an air inlet assembly. So one's going to allow air in, and that's it, part of its job. The other one, part of its job is to allow air out. Both of them are going to actually be able to let air go either direction. It's going to depend on the pressure. If you look at the way the valves are designed, there's a spring on top of them that pushes down. So if the pressure behind it is less than the pressure in front of it, it'll open up. And that's the way they work. So they're not electrical. They are spring operated, and pressure from one side to the other is what opens them up. So instead of using the weight like we did with the ESIM switch, we're going to use spring pressure on a valve. Now the vapor pressure sensor is electric. That valve is electric. There is a purge valve on here. That valve is electric. So we have to have 2 valves and 1 sensor, 2 electrically operated valves and 1 sensor to make this work. And then we use 3 pressure valves. These pictures right here at the top of the tank, those are what we call rollover valves. Part of their job is if you decide to roll the car over, they block off these holes so you don't get any gasoline spilling out of this system. So it's not just a direct hole into it. Otherwise, we could very easily dump gasoline out of the tank if we rolled the car over. That's why they call it a rollover valve. But one of the other things that they do is they help create what's going to happen when you're doing onboard vapor recovery, when you're filling the gas tank up. And we'll look at that in a minute. So first thing's going to happen is the car is warming up and got pressure inside of the gas tank. The sun's out, we're building up some pressure inside of the gas tank. And though we're not putting fuel in the tank, since we're not putting fuel in the tank, it's not on board vapor recovery. We just need to relieve this pressure so we don't create a leak by literally blowing a hose off or something. So our car is off. So some of the things that I'll point out to you, our car is not being run, so we're not purging it, otherwise we wouldn't have pressure in the tank. So what's going to happen is you can see I've drawn the red lines where pressure is going to go. So up here at the onboard vapor recovery tank, the pressure inside of the tank is higher than the pressure that's in the charcoal canister. So our charcoal canister is over here, and you can see a line that runs up here. And since the pressure in the tank is higher than what's in the charcoal canister, this valve remains closed. Our pressure is going to go through the rear rollover valve, and it's going to push the tank pressure valve open because the pressure outside is less than the pressure inside. This valve, you can see right here, the top of it is vented to the atmosphere. So since the pressure inside the tank is greater than what's outside of the vehicle, it's going to unseat, and that's going to allow pressure to go out through that valve, come through this valve to the charcoal canister. Since this pressure is higher than what's outside, it pushes these valves open, and that actually opens up the air valve assembly, the air drain valve, to dump air out of it, and it opens up the line that goes out to an air filter where we normally have fresh air coming in. Now, all these vapors had to go through the charcoal canister, so there's no gasoline fumes in them. They all got trapped in that charcoal canister, so we did not pollute the air. So that's what's going to happen if we get pressure inside of the tank, and this is normal. This happens every day. Now, every day we're driving the car, either the car cools off at night, or maybe we're driving the car and we are creating a vacuum inside of the tank. Similar thing is going to happen. Since we get a vacuum inside of the tank, the valve that are going to come into play is our air inlet valve up here, and our tank pressure valve is going to come into play right here. So now what's going to happen is the pressure decreases inside of the fuel tank, and so we don't collapse it, we're going to allow atmospheric air pressure to open the air inlet valve to let air into the charcoal canister. Then from the charcoal canister, it's going to come over to the tank pressure valve, open it up, and that's going to open the passageway to allow it into the fuel tank. See the flow that I've drawn out in red shows you the flow. So this is normal operation. This is not leak detection. This is normal operation of the vehicle as the pressure in the tank goes up and it comes down. Now, if for some reason some of this got clogged, remember this air valve assembly, we have two valves to let the that can open up if we get too much pressure in the system or too much vacuum in the system. One valve will open up only under vacuum, but the other valve opens up under pressure, and we can relieve that pressure so it doesn't blow out at you. That way, when you take the gas cap off, it doesn't try to blow the gas cap out of your hand from the pressure coming out of the tank. We don't want that to happen. That could also create leaks, and we don't want it to go into a vacuum that could collapse the tank. So that's normal operation. Now, the next thing's going to happen with this is when we're trying to purge the system. So we're driving down the road, everything's working normally. Our computer says, hey, we need to clean all these vapors out of the charcoal canister that have been created in there from the pressure going up in the tank and the fumes trying to go out through the charcoal canister. We got to get those fumes out of there because it can only hold so much. So we got to get the fumes out of there and keep that tank cleaned out. So what's going to happen while we're driving is now this other valve comes into play. Here's our purge valve. We're going to turn it on. That valve is hooked up to the intake manifold. So there's vacuum in the intake manifold. We're turning that valve on, and it will be pulse width modulated. So it's not just an open door. We're going to pulse it so we can control the flow of these fumes. Now, remember, we're not trying to suck fumes out of the gas tank. We don't want to do that. We could possibly suck some liquid fuel right out of the gas tank. We only want to flow air through the charcoal canister. So what's going to happen is our vapor pressure sensor valve is closed. It's closed off. So there's no passageway through there. So our air is going to come in through our filter, come along here, in through the air inlet valve. It comes through the charcoal canister, and it is just drawn right back out through the purge line up into the engine. Fairly simple system. Works great. That's normal. That's the normal workings of this sensor. Now, when we want to do a test, we want to test this thing to see does it work. We've got to test to see if this system is working properly. What we will do, and let me just make sure I don't think I have a picture on here of it. We've shut the car off. So you've driven the car, you shut it off. What we do is we start a timer. We start a timer, and we're going to open this vapor pressure sensor. This vapor pressure sensor is open. That connects everybody together. So if you look, that little red valve that you see right at the end of that line, it opens up. That connects everything together. And what it's going to do is it connects the tank, our gas tank, as well as the charcoal canister, all of these hoses. It hooks them up to this vapor pressure sensor. Now, we let a little bit of time lapse. And it's generally hours. So this generally happens over a period of hours. Time passes and just intermittently the computer wakes up and looks at the vapor pressure sensor and sees what it reads. If it sees the pressure go down, then we must have a sealed gas tank. So if we have a sealed gas tank, then we pass the monitor. If the vapor pressure does not drop below what atmospheric pressure is, then we don't have a sealed gas tank. We could have a fairly large leak. We could have a small leak. So we're going to see what happens. It can give it up to 20 hours or so for this to happen. Now, if after a period of time we don't see the pressure drop, then we'll do what we call a forced test, because maybe there is a big leak and that's the problem. So what it'll do is it'll open this vapor pressure sensor up. We just open up the vapor pressure sensor and we turn on the purge valve. Now, instead of air coming in here, going through the canister and coming right out, by opening this sensor up, air vacuum now can draw air out of the gas tank and it'll pull the system under a vacuum and we'll see that per drop. So if that happens, but it doesn't pass the test while it sits on its own, after a period of time, it'll set a code for a large leak. Simple enough. So let's take a look at another system. Like I said, we've got so many systems out there. There's a bunch of them. So this is another system that Toyota and Lexus used. So I keep trying to remind everybody, this is not necessarily odd to other manufacturers. Other manufacturers use similar type systems. That's a big problem with working on some of these systems. There's so many different systems out there. For the most part, I can do a lot of visual checks without knowing what type of system I have. A little bit of knowledge on how the system works, and you can be able to figure out what you're probably going to have to do and look in order to test it. But it's when you can't find your problem. When you can't find your problem, the reason you can't find it might be because you're not testing it under the right condition. The reason you're being led astray, we'll get into this next week, but you can't pressurize the system with the smoke machine, and when you're pumping smoke into it, you're seeing smoke come out of hoses, but you've replaced those components and that doesn't fix the problem. It still doesn't pass. It's because you didn't realize what's going on in the system. So remember, even though we've looked at 2 Chrysler systems, we've looked at 1 Toyota system. We're going to look at 1 more Toyota system, and you'll see there's some things that I need to know. For instance, so if we think about this for a minute, if we go back here to the system, if I was trying to push smoke into this system to pressurize it to see if I've got a leak, I'm going to have to get rid of this leak, because as soon as I put pressure in here, this valve's going to unseat. I'm going to have smoke come out through here. I'm not going to be able to pressurize it. So I'm going to cap this off right here. That's going to seal my system up and make it work. If we look at the other system, if I'm going to pressurize this with a smoke machine, I'm going to have to take a look at some problems here. If I allow pressure to build up in here, it's going to come out here. Or it's going to come out through here, one of the two. So I'm going to have to find a way to block those off so I can pressurize my system. Also, depending on where I pressurized it, because of this vapor pressure solenoid, I might only be pressurizing part of the system. So understanding what has to happen to open it up, I've got to have this valve opened up in order to test the whole system. Otherwise, I'm going to have to test it in two pieces. So I'm going to use a scan to do that. And we'll take a look at some of that next week. But this is why I'm just pointing this out to you, because now we've got another system here. And this is why we need to know how the systems work. So we've looked at two types of systems, or one that use vacuum. We looked at the one on my Jeep, that uses the ESIM switch. And then we looked at the Chrysler early, or the Toyota early system. And both of those use vacuum to test and see if they have a problem. We looked at one system on my Jeep that uses pressure to determine if we have a leak. Now we're going to look at another system that uses pressure to determine if we have a leak. And this is a Toyota system that we use. So this system is called the Toyota late system. And what it does, it's kind of interesting. I used these slides from them so I could point out. This is going to show you where we have pressure. It's going to show you where the parts are. This section over here is going to show you if you tapped into this pressure sensor. We've got a pressure sensor right down here in the bottom. So if we were monitoring the pressure, this is going to show you what's going to happen to the pressure over here. And we've got some solenoids. We got a motor here. We've got a motor. We've got an Evap solenoid right up here. We have a canister vent valve right here. And so right in here, we're going to show you what we're doing with those, whether we're turning them on or off. So we're going to go through the whole test system to see what happens with this. And this is the test. The rest of it, checking to see what happens for onboard vapor recovery and all that, you can kind of figure that one out on your own. Now, our fuel tank's over here. And like I said, let's just kind of think about this for a minute. So if I was putting gas in the car, how would the onboard vapor recovery work? Well, let's draw it out. Gas comes in, fumes have got to go out, right? So fumes are going to go out here. They're going to come up here to this valve. That is our onboard vapor recovery valve. And we're going to push this off of its seat. Fumes are going to go through the charcoal canister. Then they are going to come right out through here, and it's going to come right out through the filter. Fairly simple. Now notice that would be pressure here in this white area underneath is greater than the pressure on top. Notice this is vented right down through here. So if the outside pressure is greater or is less than inside pressure, this valve opens up and allows that to vent through the charcoal canister. We never allow it to vent straight to atmosphere. We want to catch those fumes. So that's just to show you, you can look at these and kind of figure out what's going on as you look at them. Once you start realizing what the parts are and look at how they're connected together. So we looked at how the other systems are monitoring for a leak. This one does it a little bit differently. What this one's going to do is we're going to, right off of the bat, our pump is turned off. So our pump is off. So right over here, our pump is turned off. Right above that, you'll see the canister vent valve. It is turned off. That's this one line right here. And our evap valve is turned off. So evap valve is actually our purge solenoid. That's what the rest of the world calls it. Toyota calls it an evap valve. So that's our purge solenoid. So all of those are turned off, and that pretty much means the system is vented. So our pressure sensor down here, our pressure sensor that's down in the bottom, is basically reading atmospheric pressure at this point. Because if you follow it, it has a path right out to atmospheric pressure. So it's taking an atmospheric pressure reading is what it's doing. And we're going to monitor that. That shows up our scale right here. So we got an atmospheric pressure sensor reading. Now, the next thing that we're going to do is we're going to find out, hey, what does a leak look like? And in order to do that, we're going to turn the pump on and see what happens. So now we're going to turn the pump on, and you can see up here on our graph that our pump is now on. Our pump is turned on. Our canister vent valve and our purge valve are both still turned off. And when we turn that pump on, it's going to try to pull a vacuum on the system. But since the canister vent valve is off, let's see what happens. So as this pump tries to pump air out and pull air out of the system, air is basically going to flow through this valve, down through here, and come right back over. But there's an orifice right here. This is what I want to point out. They put this orifice right here in this line. That's a 20,000th of an inch orifice. So basically what they're saying is this is what the pressure would be today under these conditions, under this temperature, if you had a 20,000th of an inch leak. And that's the reading we're going to get right here. So these are just reference points. So we started out, we read what atmospheric pressure was, and we want to know that because we got to get back to that when we're done. Then we want to know what kind of pressure would we have in the system with this pump running if we had a 20,000th leak. So all we're doing, all the system is doing right now is it's gathering benchmarks. Here's atmospheric pressure. Here's what the pressure of a 20,000th leak looks like. So now let's leak test it. So when it goes to the next step, the very next step in here, what we're going to do is we turn the canister valve on. Our pump is still on, but the canister vent valve just got turned on. And look what happens when it moves. When it moves, we blocked off the vent right here. That vent got blocked off. We opened a passageway up through the middle of this from the pump motor straight over to the charcoal canister. So basically we took that orifice out of the pressure line because now we have an open system. So now this is open. By the way, you'll see three of them. There's one right there, there's one right there, and there's one right up here. There's three blue marks that I just put on there. One right above the pump, right here. One right here before the canister vent valve, and one right here. Those are filters. Those are filters so that we don't get any dirt into the pump and we don't get any dirt into that orifice. If they clog, then you get the new component. Then you end up having to get the new piece because most of this is going to come as an assembly. You get this as an assembly, and so you get all new filters with it. So it is possible they could clog, especially if our charcoal canister came apart. But if they do, we'll get some codes that nothing's going on because nothing will flow through there if that happens. But that's what those little hash marks are that you see in there. Those are filters that are in the lines. You cannot replace them separately. So if they clog, when you trace them out and find a clog in that line, you get a new assembly. So we've turned the canister vent valve on, and now if you look at the difference in our colors, the light blue that you see on the diagram is atmospheric pressure. The yellow is we're pulling that whole system into a vacuum. So everything that's blue is atmospheric pressure. Everything that is yellow has been pulled down into a vacuum by our vacuum pump motor. And so now our pressure sensor should see a vacuum being created. So if we look over here at our graph, we're looking at this section right here. And now remember where our reference line was. This was a 20 thousandths leak. So if I run that across, notice that pressure drops below the 20 thousandth leak point. So if it drops below that, that is what we're looking for. It should be able to do that. So now we can pull it down lower than a 20 thousandths leak. That means we do not have a 20 thousandths leak. If, when we open it up, we can't pull a vacuum on it at all, that would be the red dotted line at the top. So the red dotted line up here at the top, if we can't pull a vacuum on the system at all, then that means we have a large leak. And we'll set a trouble code P0455, large leak. If we can pull a vacuum on it, but we can't get it down to what our reference line was for the 20 thousandth leak, that's this line right in here doesn't come down to what our reference of a 20 thousandth leak was. This is going to be a medium leak or a small leak. That means if we get down to the 20 thousandths, but we can't get below it, then we set a small leak. If we're only about halfway there, we set a medium leak. So this is where we're going to set our leak codes. And so if we can't get the pressure to pull down to that 20 thousandths reference line that we had at the beginning in that second step, then now we know we've got a leak. So if we make it past this section. Once we make it past this section, we're not done testing everything yet, because we have some other components we got to test. So we're going to move on to the next section here, and we got some other stuff to do. And let's see what happened. If you look up top, what happened, our pump is still running, but what we did is we opened the evap valve. So we opened the evap valve up with the pump running. So basically we created a leak in the system, and it should be a fairly large leak. And what we're looking for is the pressure to come back up. We're looking for the pressure to come back up, or the vacuum to decay, whichever way you want to put it. But we're looking for it to head up towards atmospheric pressure, because we just created a large leak in the system. If we see that, that works. If it stays down at a vacuum, then we're going to set a code PO440, I think it is. I drew a line right through the middle of it. PO441. And that's going to tell us either we've got a problem with a clogged line, or my evap valve is not opening up. So as long as that happens, we go on to the next step. If it doesn't come back up to atmospheric pressure, then we set a code for either a clogged evap line or the evap system is not working. Then we've got one more step that we're going to do in here. And just to re-verify that everything is good and all the valves move back to where they were supposed to go, we're going to go one more step, and we're going to go right back to the beginning again. So right back at the beginning where we were, right in here, the pump is on, the canister vent valve is turned back off, and the evap valve is turned back off, and we should get the same pressure that we had when we started. So if we have the same pressure here and here, then everything's good. If we don't, one of these valves got stuck. So if, for instance, if this pulled back down into a vacuum, either our canister vent valve is stuck, or this orifice is totally clogged. One of the two. So do you kind of see how that works? You got to kind of get into these systems and see what the manufacturers intended. How did they build them? What did they design them to do? Because that's what we're looking for. What are we going to do with these systems? How do they work? Every manufacturer's system is a little bit different, but they really do all work just about the same. If you can understand one, then you can kind of look at the layout and the description of the others, and you'll be able to figure them out. And that's what we're kind of working on here. Now, these systems and more are in that evap manual that I posted on Blackboard for you. Look over that system. See how it looks for you. It's very, very good information. If you want to download it and save it on your computer for future reference, you're more than welcome to do that. But what I want you to do is keep looking through these systems and kind of get an understanding of the pieces. What's a vent valve do? What's the purge solenoid do? Some systems have pressure pumps, some have vacuum pumps. Some don't use a pump at all. They use natural vacuum. If you want to see a really cool YouTube video, go in and type in natural vacuum destroys a tanker car and watch it. You'll see what happened. Um, I don't know if this was really staged or what went on. What I was originally told when I saw it the first time is this happened because a guy was steam cleaning the inside of a tanker, big train car, great big huge tanker. He was inside of it. There's a big um, uh, whole big lid on the top of it, and he was down inside of it, steam cleaning it to get the inside of it sanitized. And because I think what I was told originally, first time it happened, was it was a milk container that was carrying milk, and so they had to keep it very sterile. So he's inside steam cleaning it with really, really, really hot, high pressure steam. Gets done with it, gets out of the tanker, didn't think about it, closed the lid, closed the valves off on the bottom, and it cooled off. When it cooled off, it collapsed. It's a really cool video. Go in, you'll see it. It's a tanker car, and it's folded in half in the middle. It went from being a tanker to it looks almost like the Oscar Mayer Wiener hot dog car. Yeah, so go in and study those. Hope everybody's still doing safe. I don't see any reason for us to change anything with what we're doing. What's coming up next week is on Monday, I'm going to go through doing testing of these systems. I did not bring the testing machine home with me, so I can't show that to you personally, but I've got a couple of videos that walk through it to show you how to use what we call a smoke machine. It's an Evap system tester. Most all shops are going to have one. Generally, it's a shop tool that they have, and it's used to help us find leaks in the system. But I got to kind of know how the system works because I might have to actuate some of these valves with the scan tool. I might have to use something to block off ports so we don't release the pressure out of them. So that's coming up Monday, or Tuesday rather. We're going to do that on Tuesday. Then we're going to take a unit test on Thursday. And the unit test will involve this Evap system that we've been going over. It'll involve that. Then the following week, the last 2 days of class, on Tuesday, we're going to go over some vehicle communications problems. How do the cars talk to you? I'm going to go over only 2 bus systems with you, the LIN bus and the CAN bus. Those are the 2 most important, excuse me, I got the hiccups. 2 most important bus systems. CAN bus, kind of misunderstood, but we're going to go over it. It's very easy to diagnose what goes on with it. I've got a document for you that should take care of that and cure a lot of those problems. You'll be able to impress people by being able to pull up an oscilloscope pattern and look at it and say, oh, you got this problem with it. It's actually not hard to diagnose. The other bus system is called the LIN bus, L-I-N. That's one of the most common interior buses that we use for modules inside of the car to talk to each other. Most manufacturers use at least those 2 buses. There's also about 6 or 8, 10, 12, 30, 40, 50 other bus systems. Just like with the Evap system, if I have a general understanding of how the system works, I really don't need to know all the details of it. I just have to understand how it works so I know how to test it. What am I looking for? So that's what's coming up. Questions, email, send me a text. Everybody should have my numbers. If not, you know how to get hold of my email. Everybody's emailed me. My cell phone number is posted in the announcements on Blackboard. You can send me a text there. If you will, just send me a text, say, hey, hi, we're doing good, because I do miss seeing you guys. I really, really, really do. I hate not seeing you. Hopefully, I'll be able to catch up with you somewhere sooner or later, and we can meet up again. But we're getting close to the end of this semester, and I believe most of you guys are getting close to graduating and getting your diploma. Yeehaw, hot dog. So, see you next week. Talk to you later. Thank you very much for watching.